We're asked to find the domain in the range of two equations. The first equation A is y equals the square root of 2x minus 1, and the second one is B equals, the second one B is x equals the absolute value of y. So first we'll look at the equation in part A, and what kind of restrictions might we have on the square root of 2x minus 1? Well, that's an even index root, and you know there's a restriction on what you can take the even index root of. So part A, the domain is equal to, you take the radicand, that's the stuff under the radical sign, and you make sure that it's greater than or equal to 0. You set it greater than or equal to 0. And you do this because the radicand of an even index root can never be equal to a negative number. Okay, let's solve for x. We move the 1 over by adding it to both sides. And then we divide both sides by the coefficient of x, which is 2. We get x greater than or equal to 1/2. And we'll write our domain equal to interval notation. Boxy bracket, 1/2, comma, infinity. The smallest value is 1/2, and it includes it. That's why we put a boxy bracket. And then the largest value goes to infinity with a round bracket. Infinities always get round brackets. And we wrote it in interval form. Okay, let's consider the range. Well, what do we know about the y values? Look back, I'm going to pause this for just a second. Look back at the y for this part A. Y is equal to an even index square root. If it's equal to an even index square root, it's the square root of 2x minus 1, then we know that the answer to that square root has to always be non-negative. Therefore, y is always going to be greater than or equal to 0. And we write that in interval notation. The range is equal to the smallest value, 0, including 0, so we put a boxy bracket, and the largest value is infinity with a round bracket. Okay, let's look at part B. The equation was x equals the absolute value of y. Now think about what kind of restrictions could we have for the domain. What kind of restrictions will we have on x? Well, x is equal to an absolute value. What do we know about absolute values? They're always positive, or I should say they're never negative. They could be 0. And that's the way we say this is absolute values are never a non-negative number. They're always greater than or equal to 0. So we recognize when we're working on the domain, the x value in this case is equal to an absolute value. That implies the x value has to be greater than or equal to 0, and the reason is because the absolute value of anything cannot be negative. Okay? And that implies if x is greater than or equal to 0, in interval notation, that means the domain of this function is equal to the smallest value, that's 0, and it can equal 0, so we put a boxy bracket on 0, all the way up to infinity with a round bracket. Now the range, what about the y value? Well, you know, there's no restriction on what you're allowed to take the absolute value of. As long as it's a real number, it'll work. So we're allowed to take the absolute value of any real number. So there's no restriction on what y can be. Y is inside the absolute value bars. It's everything. It's any real number from negative infinity to positive infinity. And of course, we put round brackets on the infinities because they're not even real numbers. And we're finished.